All right, we're back again. We're working on the 2019 AP Calc AB and BC FRQs. This is number 4, which is on the no calculator section. It's the same for both the AB and BC test. All right, let's get started. So, right off the bat, I see a picture and volume, and so this I can already tell might be a related rate question, but let's read and we'll find out. A cylindrical barrel with a diameter of 2 feet contains collected rainwater, as shown in the figure. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height h of the water of in the barrel at time with respect to time is modeled by dH dt equals negative 1/10 square root h, where h is measured in feet and t is measured in seconds. The volume of a cylinder with radius r and height h is pi r squared h. Okay, so this looks like it's going to be a differential equations problem. Might also be a related rate depending on what they ask. Okay, so part A, find the rate of change. Find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. Half the battle on the AP test is dissecting the words that they give you into mathematical statements, into the things that you know about, that you've learned in calculus. Okay, so anytime you see rate or rate of change, that should be indicating derivative. Respect to time says that you're taking the derivative with respect to t, so it'll be like dt. And what are we taking the derivative of? The volume of water in the barrel. Great, so that's what we're trying to find. We're trying to find dV dt. That's what the rate of change of the volume in the barrel with respect to time is, dV dt. And when do we want it? When our height is 4. That's our goal. That's what we're trying to find. So, well, what do we know about the volume? Well, they tell us that the volume is pi r squared h, so we're probably going to want to use that equation. If we have v equals pi r squared h and we want dV dt, we can get it by taking the derivative with respect to time of the whole equation. So, doing that, on this side we just get dV dt, and on this side, being careful to note that we're taking the derivative with respect to time, not with respect to r or h, right? So we have to think about whether these variables, r and h, are changing with respect to time. So notice here we have a cylinder that has a fixed radius, right? The diameter is 2, so the radius here is 1, right? R equals 1. Since it has a fixed radius, the radius is not changing with respect to time. In other words, r is a constant, right? In fact, we could probably even just plug it in to our equation because it's not changing with respect to time. But the height is changing. It's decreasing with time, right? In this way. So, I think I will just replace r with 1. So this is really 1 squared. Okay, so that's just 1. And this is pi times then dH dt, the derivative of h with respect to time. Right? And if this had been like h squared or something, then the derivative of that with respect to time would be, you pretend first you do power rule normally, 2h. And then by chain rule, you multiply by dH dt. Okay, just wanted a refresher there. Great. And we know what dH dt is because they told us. So this is pi times negative 1/10 square root h And we said we wanted this when h is 4. So our answer is going to be negative pi over 10 times square root 4, which is 2. So this is, when you simplify, negative pi over 5. And we should always have units, but they also tell us we need to indicate our units. So to find units, you should think about, well, what are the units for our volume and what are the units for our time? Well, they tell us that time is measured in seconds. And since the radius and the height are measured in feet, the volume is going to be cubic feet, right? So this is going to be cubic feet per second. That'll be our answer. Okay. Part B. Part B says, when the height of the water is 3 feet, so is the rate of change of the height of the water with respect to time increasing or decreasing? And explain. Again, breaking down the pieces and the terminology. The rate of change of the height of the water, that is dH dt. And they want to know if it's increasing or decreasing. Remember, if a function is increasing or decreasing, is the same as saying its derivative, its slope, is positive or negative. So, to determine if dH dt is increasing or decreasing, we should take its derivative and see if that's positive or negative at the time indicated, when h is 3. Alright, so we're looking for the derivative with respect to time of dH dt. So we know that dH dt is given by this negative 1/10 square root h. Perhaps you want to, before taking the derivative, rewrite that as negative 1/10 h to the 1/2. Then we can use chain rule to take the derivative, right? Again, remember this variable is h though, and we're taking the derivative with respect to t. So we're going to have to use a chain rule at some point. But first we do power rule like normal. So we bring down that 1/2. We subtract 1, so we get negative 1/2. And then we remember to multiply by the derivative of the variable here, or the inside, which will be dH dt. We've got negative 1/20 times 1 over square root h, that's that h to the negative 1/2, times our dH dt. Well, again, we know what dH dt. That's negative 1/10 times square root h, right? As it, it always was. And now, if I simplify these, I notice that square root h's cancel, and I multiply, and I get 1 over 200. Okay, so what this is saying is that the second derivative of h with respect to time is 1 over 200. Always, because there's no h to even plug in anymore. They canceled, right? For all h, for all heights, the second derivative is positive. So that tells me that for all h, and for all time really, dH dt is increasing. And that is going to be our answer. Okay. Lastly, part C. So notice that up to this point, we have not solved this differential equation at all. That is typically the case when you're doing FRQs that involve a differential equation. You usually don't have to actually solve the differential equation until part C, the last part. So it says now at time t equals 0, the height of the water is 5. Okay, so they're telling us that h of 0 equals 5. Now they say use separation of variables to find an expression for h in terms of t. In other words, solve the differential equation for h. Alright, so we start with our dh dt equals -1/10 square root h. Step 1 is to separate our variables, so get all the h's on the left side and all the t's on the right side. So if I divide by square root h, I'm going to have 1 over square root h dh. I multiply by dt on both sides. I have -1/10 dt. Once you separate your variables, you then can integrate both sides because we have dh and we want h. So if we integrate, we should get back to h. Now maybe before I integrate this, I'll rewrite this as h to the -1/2. And on this side, when I integrate, this is a constant. My variable is t, so I'm asking for a function in t whose derivative is -1/10. So that's going to be -1/10 times t, and I always have a plus c when I integrate, right? And now the integral of h to the -1/2, I'm doing, reverse power rule here. So I have to add 1 to the exponent, so that gives me +1/2. And then I need to divide by that new exponent. So this is like 1 over 1/2, which will become 2. You can always check this by taking the derivative. If I did the derivative, I'd bring down the 1/2, I'd cancel the 2, I'd get h to the -1/2, which is what I have here. So you can always check your antiderivatives by just taking the derivative again, seeing if you get back where you started. So this, recall, is the general solution to the differential equation, or perhaps if you solve directly for h, you might call that the general solution, but it's the one that involves this plus c. It's a family of solutions. C could be any number here. We want a particular solution since we know that our function goes through the point 0,5. So I would recommend finding that value of c right now by plugging in t equals 0 and h equals 5. So we have 2. I'm going to rewrite this as square root of 5 is equal to -1/10 times 0 plus c. Okay, so this gives me that c is, this goes away, c is 2 root 5. So now I have 2 square root h equals -1/10 t plus 2 root 5, plugging in my c. And I wanted to solve for h. So dividing by 2, I have square root h equals -1/20 t plus root 5. And then I have a square root I need to undo, so I square both sides. And I get h is equal to, I'm just going to keep it like that, -1/20 t plus root 5 all squared. We're going to leave it like that. That's our function h. You could also write h of t because it's a function in t. Okay, great. And that is problem number 4.
Guys, don't forget to subscribe and hit that bell for all future notifications.